Alright, in this first section, we're going to circle every subset that applies to the given number. So we want to make sure that we get every word that describes the number. If it's a natural number, if it's a counting number, it's also a whole number, it's also an integer, it's also a rational number, and they're all real. We're going to circle that for all of them. So on this first one, we're going to start out by probably dividing that and seeing what that number looks like. 1 divided by 19. The problem is we don't get a repeating decimal, and we don't get a decimal that stops. Even though we don't have that, any fraction is really just a ratio, which makes it a rational number. Alright, so even though we don't get a repeating decimal and we don't get a terminating decimal, it's still a rational number because it's a fraction. Any fraction not involving pi is going to be a rational number. Alright, we also know that all of these numbers are going to be real, so instead of just circling one at a time, I'm going to go ahead and just circle all of those. Alright, on number 2, that's a decimal that stops. The 7 really doesn't matter that much. It's just a rational number because we do have that decimal part to the number. On this one, we have a negative 7.0. That's really the same thing as negative 7, which is an integer. It's also a decimal that stops, so it's rational. Also, any integer has to be rational. Letter D is the square root of 9. That's really the number 3. That's a counting number. That's a number that we would count on our fingers, or if we were to count the number of pencils in a pencil case, you'd start with the number 1, then 2, then 3. It's a counting number. Any counting number is also a whole number. It's also an integer. It's also a rational number. We could write that as the number 3.0, which is a decimal that stops. This next one's a decimal that doesn't stop and goes on forever. Anytime we take the square root of a non-perfect square, 10 is an example of a non-perfect square, we get a decimal when we do the square root. That's an irrational number. 1 is a natural number, that's a counting number. Anytime it's a counting number, it's also all of the 3 next to it. It's a whole, integer, and rational number. 15 times pi doesn't change it from an irrational number. Pi is irrational. Multiplying by 15 doesn't change that. 1 divided by 9 is the repeating decimal 0.1. It's also just a fraction, so we know that's a ratio or a rational number. And that's the exact same number, actually. It's 0.1 repeating. Repeating decimal is always rational.